Hello, everyone, and welcome to GCP Next 2016, the largest gathering of Google Cloud users to date. I'm Kit.
And I'm Brad, and we're going to be your hosts for this tour of GCP Next that you'll get to decide. There's going to be an opportunity for you to vote on where we go in just a minute.
So we're here in sunny California, San Francisco.
Right, on Pier 48. I understand we have over 3,000 people coming to GCP Next live here.
That's right, and online, there's 10,000 more all around the world on a live stream that, by the way, we're broadcasting live on Google Cloud.
That's fantastic. I understand there's viewing parties all over the world, in Africa, North America, and Europe, and Asia. If you got up early or stayed up late to be with us, thanks a lot. We appreciate it.
So over the next couple of days, you're going to hear from our executives, our customers. You're going to see some great technology. Customers like
Spotify, for example, who's really investing in building what's next on GCP.
So right now, we're at the Google Cloud Playground. We're going to see some installations that feature Google technology. And to tell us about it, here's Greg Wilson.
Hey guys, how you doing?
Hey. Doing well. Say hey.
Hey everybody at home, welcome to the playground.
Hey Greg, so I understand your team helped put together this playground. Can you tell us what this is all about? Why are we doing this?
You bet. So we've got a ton of announcements coming today, things that developers hopefully will get super excited about, but developers want to get their hands dirty, they want to get in, they want to see it for real, right? So what we put together, we have a few things. Over here to the distance, we have a theater. It's a circular theater, 8-foot tall screen showing a video from a data center in the Dells, Oregon. And it's actually a spherical video.
Oh, wow, that'll be cool.
So we'll be announcing that during the keynote. It's going to be pretty awesome. But anyway, it's been super popular all morning. The other side of that, we have a game that we've put together called Query It. And Query It uses Google BigQuery. And we're querying a bunch of different data sets, and they'll tell you more about it. But it's a fantastic game running real queries against billions and billions of rows of data.
Wow.
We might have to play that later.
Oh, yeah.
Yeah, it's pretty good. The far side, we have a photo booth that's using our Vision API to detect emotion and other characteristics of the person being taken, hence the name Emoto Booth. Emotions.
I like it, yeah.
So we got that going on, and that's doing really well. In front of that, we have the GCP podcast. They're actually doing some interviews here, just impromptu.
Oh, wow. Oh, so there's GCP podcast. Where can our viewers find that?
As you might imagine, gcppodcasts.com.
Oh, so, that's awesome. I listen regularly. It's a great podcast.
It's really growing fast. We've got a ton of listeners. We've already had a few show up wanting autographs from the guys. So
that's cool.
Yeah. So behind that, we have a table with some little GoPiGo robot cars set up, and they have a camera that's taking pictures and sending it to our Vision API.
Oh, cool.
And identifying what it sees, and it speaks, and you get to see the console, the actual JSON coming back from it. So that's a lot of fun. And really a good use of the Vision API. It's a couple of surprises with that you guys will find. And then last but not least, we just have some Tetris games for people to hang out and play some games. But we actually picked Tetris for a reason. There's a metaphor with Kubernetes and the way we do container management and orchestration that it goes with. So yeah, encourage you guys to check it all out.
Oh, wow, that sounds fantastic.
Well, thanks, Greg.
Are we going to be able to do all this?
Well, for those of you at home, you're going to see a vote come up on your screen in just a little bit. You'll have about 90 seconds to fill it out and choose, and you're going to decide where we go. But Brad and I had a chance to look at things earlier.
Yeah, I'm thinking robots. What do you think?
Let's check out the robots.
So we're going to start with robots while you vote. So let's go over here to robots and see what's going on. So yeah,
for those of you just joining us, by the way, we're hosting, this is live coming to you from San Francisco. This is GCP Next 2016, and we're going to walk around and show you some of the stuff going on here at the conference.
All right, let's check this out.
Sarah.
Hey, it's good to see you.
Hey, good to see you too.
So what's going on with all this?
Hey everyone on the live stream. So what we have here is the Cloud Vision robot. It's an image detection robot powered by the Cloud Vision API.
Oh, that's cool.
So what it can do, it can recognize objects in an image. So here I'm holding up a flower to it.
Okay.
And here's the dashboard of what it's seeing.
Show that to the audience.
Yeah, so it should be able to recognize that.
Oh, it says flower.
Yeah. So
that's pretty cool.
It uses the label detection feature of the Vision
API
and
the camera is right here with the camera, or how is that?
So that's actually an ultrasonic sensor. The camera is here. It uses the sensor just so it doesn't bump into things.
Oh, that's great.
It can also recognize faces in an image.
Faces? Oh, Kit, I think I got to try this.
Let's get your mug in there.
All right, so I get down here. Okay. Is it seeing me? Am I in it?
On the dashboard, we should be able to tell. So it drew a box around. Oh, it sees me.
Should I be higher? Oh, it's running away from me. What does that mean?
Oh, it saw you smiling.
Okay.
If we see it drew a green box around your face there.
Okay, cool. Oh, it's coming to me.
So it'll come towards you if you're smiling.
Oh, there it
There
comes.
goes.
All right,
There
that's
it
cool.
goes.
So Sarah, you built this? Tell me a little bit about this robot here.
So it's a hobbyist robot kit that we got, and it's got a Raspberry Pi. So you can think of the Raspberry Pi as the brain of the robot. The Raspberry Pi is running some Python code.
Yep.
So it takes a picture using this camera. It sends the picture to the Vision API.
So it just calls the REST endpoint for Vision?
Exactly, using the Python code. And then the Vision API returns a JSON response of a bunch of data in the image. So it can tell what objects are in the image. That was what it did when I held up the flower.
Yeah.
And then it can also tell what faces in the image. It can tell where the faces are. If you're happy, as you saw, it'll come towards you. If you're sad, it'll go away from you.
So I think my kids would really love this setup. How much, where'd you get this? How much is it?
Definitely. The whole thing is about $400.
Okay.
It's great for kids, too. They have great assembly instructions on how to put it together.
So you're using machine learning here. Are you machine learning? Is that your background? Are you an expert in it? How did you get into that?
No, actually, the really cool thing about the Vision API is you don't need to be a machine learning expert to use it. You just need to send the API a REST request of your base64 encoded image, and then it can return a bunch of data on what's in the image. Yeah.
That's cool. So obviously we're just doing a demo here, but what do you see customers doing with this?
Yeah, great question. So the Vision API, the robot is just a cool demo we built to demo the label and face detection features of the API. But there's a couple other features that are pretty awesome. So it can do text detection. If you pass it an image of text, it'll run OCR on that text to tell you what it says. And then it can also tell you what language it's in. So for example, if you've got users uploading receipts and you want to auto-categorize expenses, the Vision API could read the text of those receipts and then send it back. Some other features, it can do landmark detection. So if I were to send it an image of the Golden Gate Bridge here in San Francisco, it would be able to return the latitude, longitude coordinates of where that is, along with the name of it.
So recently we launched Google Photos that does some of the same stuff. Is that related?
Definitely. So the Vision API uses the same machine learning models that power Google Photos. It basically gives developers access to the technology behind Google Photos. So you can do things like, if you have a large catalog of images, you can understand the metadata of what's in those images. It's pretty powerful.
That's great.
Yeah.
That's cool.
So if I wanted to get started, what do you recommend is a good way to get started playing around with the Vision API? What should I try?
Definitely. So it's available to use today. Any of you watching on the live stream can go check it out.
Oh, wow.
If you go to cloud.google.com/vision, you can read the documentation, get started. We've got a bunch of samples, so you can build a Vision API app in any language. I built a Swift app that uses the Vision API. You don't need to use Python.
Oh, that's pretty cool. Yeah, so tell us a little bit about the architecture of this. So this runs Python code on the device. And then what does it talk to?
So it calls the Vision API, and then the Vision API returns some JSON data. And then we're actually writing that JSON data to Firebase, which is a real-time database.
Oh, cool.
And that's what we use to power the web dashboard.
Okay, cool.
So Firebase is listening. This is just a JavaScript app that's listening for changes to the data, and whenever a new image is taken, it'll post that image in the dashboard and then display any metadata from it.
Yeah, that sounds fantastic.
So what other objects can it detect here? Do you guys see you got some sunglasses around and a cup? What else can it do?
It can detect pretty much anything. So.
Oh yeah, let's play with this a little bit.
Actually, that one's connected to this robot.
Oh, okay. Oh.
Over here, and we can hold up some sunglasses and see what's aiming to identify those.
Yeah, it's seeing this vehicle right now.
Let's see.
Okay, yeah. So the sunglasses have got in the frame. Singing, that's pretty close. I like it.
Let's see, does it get the sunglasses yet?
It's got pet and hairstyle. That's your beautiful hair that it's seeing. Okay, great.
It saw me smiling.
That's awesome. Yeah, so what was it like to build this? Like, what was the development experience like?
So it was actually my first time doing any sort of development on a Raspberry Pi, and I was surprised how easy it was to build. The site where we got the robot from had great instructions on how to do it. It's pretty easy to write the Python code.
So you wrote on your laptop and then uploaded the Python code
to the Raspberry Pi.
To the Raspberry Pi
exactly.
running there. Okay, great.
So with the with the machine learning, a lot of it has to do with like training sets and building out all those like tagging of content. When you're coming into this with Vision, my understanding is you really have to do that, or you can do that. Can you talk about that a little bit?
Yeah. So the Vision API is using pre-trained models, so it doesn't require developers to build and train their own models to use it.
Yeah. So literally, I can just take my library of images I have at home, upload them, and it'll tag all of them.
Exactly. Yeah. Just need to send the API a base64 encoded image string, and it'll return a bunch of data about what's in those images.
Yep.
And if you want to learn more about it, I definitely recommend tuning in for the keynote, which is happening shortly.
Oh yeah. So what
Yeah.
are we going to get some scoop on what's next? What's coming next in this?
So I
in
can't
this
reveal
area?
too much, but all I can say is you should definitely stay tuned for the keynote.
All right. Yeah, you heard it here. So yeah.
All right, so thanks so much, Sarah. We're going to move on to our next installation. It's great to see you.
Yes. Thank you. Appreciate it.
So we just got the vote. We're getting told here that.
Oh right. Looks like the data center tour is next.
All right.
So
we're going to head over that direction.
That's
I think we're going this way,
I know
Brad.
the data
Lead the way.
center is one of my favorite things. I actually got a chance to see the data center not too long ago. So this, I think
They won't let
you're
me in the
gonna
data
love
center,
this.
actually.
Oh really? It's because of that thing.
Yeah, we want to talk about that. So if you're just joining us, hey, we're here in GCP Next 2016 in San Francisco, California. Tons of people here. We're having a great time. We just checked out some really cool robots with machine learning.
And we're doing this tour that you get to decide where you're sending us. We just checked out the Vision Bots. We're heading over now to check out a great tour of the data center with Sandeep.
So if you ever wonder what's inside the data center, I guess we're about to find out. Sandeep.
All right, Sandeep, it's good to see you. Yeah, so tell us what's going on here.
So let's go inside.
Oh, great.
Yeah. So this is a 360-degree tour behind the scenes at one of our data centers at the Dalles, Oregon.
Wow, so they let you in the data center?
That's right. So we had to go through a really big chain of approvals to do it, but it was worth it.
Oh, wow. So I understand even Googlers don't get a chance to go in this.
That's right. So most Googlers are not allowed inside a data center. Our data centers are really locked down facilities. We only want people who have a good reason to be there to actually go inside.
So for people at home, maybe they're wondering, like, why does the data center matter? I mean, we're in the cloud. Why does the data center actually matter?
So you might think, like, you click a few buttons and you spin up a VM and there you go, right? But that VM has to run on actual hardware somewhere, right?
Oh, that's where my VM is running, on that machine right there.
Possibly. So it has to run somewhere, and where it runs actually makes a huge difference, right? So we talk about power efficiency, reliability, how green and environmentally friendly your servers are.
Security,
all that makes a huge difference, right? So when you're picking a cloud provider, it's important to keep those in mind. And we're really proud of our data centers, so we want to kind of show them off, give people a chance to go behind the scenes, put on a cardboard, and actually look around and feel like you're in a data center.
Oh, yeah, so this is like a 360-degree video.
Exactly, so we're actually going to launch this on YouTube 360. You can go home and watch it as a 360 video, so it feels like you're actually there when you put
So
on.
you can physically move the phone around and it scans.
Hey, what's going on behind us right here? This looks really interesting.
So we take security pretty seriously. So what we're doing right now is shredding a hard drive. So once a hard drive goes out of commission, we actually completely wipe it. We have another team that checks out that it's completely wiped, and then we just put it through a giant machine like that and turn it into scrap metal.
That is awesome. That's data security at a new level.
Yes, it's awesome. It also makes a lot of sparks.
Tell us more about shooting this. What was it like to be there? How did you get through that experience?
So we shot this over a course of 1 week, and in early January in Oregon. So outside it was really cold. Inside though, we run our data centers pretty hot, around 80 degrees Fahrenheit, and so this allows us to get more efficient data centers because we're not pumping so much air conditioning or whatever in to cool it. And so it's really hot inside. So, and I wore the same stuff in every single scene. So yeah, super cold, super hot, but we do what we have to do.
And the device you use to take the pictures, what's that like?
So we had a 360 camera rig that we brought with us, and it was pretty interesting because we couldn't have anyone else in the scene. So we had to jump out of the way and hide. It was kind of funny, and we had to do it all in one take. So it was pretty interesting. But
I've been noticing there's a security guard in each one of these scenes. Did somebody follow you around and make sure?
So, every place we went, we had at least one person from security always with us. Wow. We did not want anybody to kind of go the wrong place, so security was very tight the whole time we were there. And there's another Easter egg. I'll let you guys find that on your own.
Oh, careful viewers will find it.
So everybody knows that Google's been investing in data centers for a long time.
Yep.
And for Google Cloud, we just announced 2 new data centers this week. Can you talk about the investment that Google's making in data centers?
So Google Cloud platform really started as, we have this great internal infrastructure that Google engineers are able to leverage to build applications. Why can't everyone leverage this? So we invented Google Cloud Platform so other people could take advantage and leverage our infrastructure. And we don't want to stop there. We want to expand our fleet, make people, wherever they are, be able to run their workloads on Google Cloud. So we're definitely investing a lot into our data center infrastructure. And
this is a cooling tower.
So I know there's a lot of redundancy in the data center, multiple power supplies. Can you talk a little bit about that?
Definitely. Yeah, so one thing I really learned going behind the scenes was every stage of the way has redundancy, right? So our software is redundant, our clusters are redundant, our hardware is redundant, our power is redundant, our network is redundant. We always have multiple redundancies, so even if something goes bad, we can just shift and you don't feel that impact as much.
Right, our customers don't know that if there happen to be a power issue or cooling issue.
So I was told we could lose a whole cluster and live migrate VMs from one cluster to another without any noticeable impact.
So for those people who maybe don't know about live migration, can you talk about what live migration is and how it works?
Yeah, so live migration is a really interesting thing that Google Cloud does. Most cloud providers might have a maintenance window or something like that where you had to shut down your VM and start it up again, right? What we do is we just live migrate your VM. So it's running and we just move it to another hardware host without you ever noticing.
User doesn't even know.
Yeah, so that's really possible because of our networking stack. So we talk about Jupyter and things like that, and it gives us 1 petabit per second of bisectional bandwidth. It's more than the entire internet in our data center. So we can literally lift and shift the whole VM live. It's ridiculous.
Wow, that's really impressive.
Yeah.
So you talked a little bit about the security, but I understand you actually had to get a retina scan?
Right. So when you watch the video, I go through something called a circle lock. And what a circle lock does is it uses dual authentication, right? So I need my badge, which is one. Right?
Check,
But that's not
I have
good
one of
enough.
those, check.
Yeah. So everyone has one of those. I also need my eyes. And you can't steal my eyes, or I hope you can't. That would be kind of weird. So I actually got a retina scan when I visited a data center, and every time I had to go into the server floor, I had to badge in and scan my eyes. And it only allows one person in at a time.
So that's to protect the physical access to the machines.
Yeah, and inside there we have even more security with metal detectors. We have a lot. I can't talk about everything we have because reasons. But yeah, it's awesome. I mean,
so where can people find the 360 video? You mentioned YouTube. Is there a good place for people to go?
So this will be on the Google Cloud Platform blog. That's probably the easiest way to find it. We also have a URL that we will share at the keynote.
Thanks so much for showing us around the data center.
This was fantastic.
Awesome. I'll see you guys. I hope you guys build what's next.
Awesome. Thanks.
All right, so we're going to move on now.
So yeah, I'm told the next one up in the voting is the Emoto booth. So we're going to go check out the Emoto booth and see what that's about.
If you're just tuning in, welcome. You're hearing from us live here at GCP Next in California, GCP Next 2016. We've already checked out a couple of cool installations at the playground, which is, first we went and looked at the robots that are using the Vision API, the Vision bots.
Cool. That was fun to play with those.
We saw the data center. We actually got to just walk inside the data center right here on the floor, which was really fun. And now we're going to go check out the Emoto booth. And
and we're still a few minutes away from the keynote starting, but this place is really starting to get packed. I see people from all over the world here. Really fantastic energy here in the room. Oh, and I think we found Julia. Hey, Julia, how are you doing? Oh. Good.
I'm well.
So tell us about the photo booth going on here.
Well, I know it looks just like your average photo booth, but it's actually so much more than just a photo booth.
Oh, tell us, really, what's more?
Well, as you can see, we've got someone taking pictures, and what happens with those pictures is that we send it up through the Google Cloud Vision API, and we start detecting emotions, so joy, anger, surprise, sadness.
Can you make people feel the emotion, or you just detect it?
So our excellent photographer has us make faces.
So should we go try it out?
I think we should.
Okay, let's go do it. Okay, so we come stand here. All right. Okay, yeah.
Okay, so while they're taking a picture.
Okay, big emotions.
So they're just going to get their picture taken here while we, we're going to watch them do it. It's going to be a lot of fun. my understanding is this booth is, basically what they're doing is they're taking the photos and they're going to take the raw data, send it up to the cloud through the Vision API, and from there we'll be able to see actually the emotions in those pictures. So we're going to see if it works. Brad is being very sad right now. We'll see how this goes. Surprised. Okay, let's see if we can.
Fantastic. I think we're done with this.
Right.
Should we go check out
Let's
see
go
the
check
results?
it out. Yeah, that'd be cool.
All right. So, Julia, tell us a little bit about how this was created.
Well, we've been working with Instrument, an excellent agency, and they've been developing from concept to implementation this entire experience. So they've been using the Vision API and just using the sentiment analysis capability.
So what's going on the board here? Oh, that's pictures of us.
Yep. So you can see it's detecting our faces as well as features on the faces. So it detects your eyebrows, your mouth, your nose, etc.
I see. So each one of these points is it detected that point on my face.
Exactly.
Oh, that's a great sad picture.
You can see the output of the JSON below it. And all the way on the left, you can see the emotions that it's detecting. So it's detecting possible, likely, very likely, unlikely, etc.
And this is the actual JSON that the Vision API returns.
That's correct. And you can see based on that JSON, we're painting the image with colors.
Oh.
So surprise
it's
and
kind of orange over here for joy.
Yeah, so joy is yellow, purple is surprise, sad is blue, and anger is, of course,
Red.
Got to be red.
Correct.
So how for our viewers at home who might want to use something like this, how are people using this in the real world? Where does this help them?
Well, we're seeing people do mass analysis over cloud storage buckets, so they can detect whether the images they're in have been experiencing an emotion. But you can really think of how this would give a lot of power back to the developer, the company, because they can detect maybe what their customers are feeling, make good decisions about what attitude to take with them based on what the API returns.
Yeah, and before the Vision API, you could do this, but it would be really difficult. It would.
Yeah, so sentiment analysis on text has existed for quite a while.
Yeah.
But images is a much harder problem, right?
Right.
Mm-hmm. So, and here we're basically using a machine learning model that we've pre-trained over a lot of images to detect faces, to detect emotions, etc. And developers can basically just use this as a service. So if you can make an API call, you get machine learning APIs or machine learning models as a service, which is pretty powerful.
And now you're a machine learning expert?
I wouldn't say expert. I have enough knowledge to be dangerous, I think. But I'm not an expert.
So it's available today, so people can use the Vision API today. How do they go get started with that?
That's correct. So the Vision API, you can get started with the product page at cloud.google.com/vision, and that has a link to the developer documentation as well as some samples that we've created. And it's in beta right now.
All right.
Stay tuned.
So can you talk more broadly about the different machine learning offerings that we have in Google Cloud, like the other APIs?
Right, so there are a couple other ones that we can talk about. They too are machine learning models as a service. We have the Translate API that lets you translate to and from different languages. And that's really easy to use, and we've had that available for a good while. We've also had the Prediction API, which allows you to predict things given data. It's also a RESTful API. Yeah.
All right. Well, thanks a lot for showing this booth. Looks like you've got a long line of people that want to try it out, so we'll let you get back to that.
Sounds good. Thanks so much for stopping by.
Thanks so much. All right. So we're moving on. We got the note here. Let's see what's next.
So where are we going? Oh, we're going to Query It. That's a game show we could do. We get to try.
All right.
So
game show time.
Great.
Hey, if you're just joining us, hope you're having a good time seeing the floor with us here at GCP Next 2016 in San Francisco, California. I'm here with Brad, I'm Kit, and we're your hosts.
We're going to do this live stream tour to give you viewing online a sense for what's going on here at Pier 48 in San Francisco.
So we've
as you can see, it's really filling up here. People are starting to get ready for the keynote, but we got a few more minutes to check out some of the cool booths that are here.
Yep, and we've already seen some cool machine learning stuff. We saw the Vision API. Brad got his picture taken. That was kind of fun.
Yeah, I think those were great photos over there.
We get to go right inside the data center, and you'll be able to as well this afternoon, which is kind of fun.
That's pretty fun, yep.
Okay, so here we are.
Oh, look, we're with Felipe here.
Felipe.
Yes, good to see you. Good to see you. So what's going on with this booth?
Yeah, so here we are playing a trivia game powered by BigQuery, going over gigabytes, terabytes of open data.
Yeah.
Would you like to play it?
Oh,
Would
a
we
game?
like to play?
Oh,
Yes.
let's play. All right, so
All
I'll
right.
take this side.
Okay.
Okay, so
So here we go. We pressed start.
Okay,
Let's get ready.
whoa. I got to set my mic down for this.
yes. So you're going to get a question over the Reddit dataset. These are all of Reddit comments.
The front page of the internet.
Exactly where I go.
Okay, what director was mentioned in our movies the most in the past month? I don't know how to spell Scorsese, so...
Yes. Give me a hint.
What's the biggest movie this last month?
So Star Wars.
That was from December.
Give me more.
Deadpool. I don't know.
I don't know.
But I don't know the director.
Well, you did. I think I win by default.
Okay, so tell us what's going on. What are we seeing with the query?
Yeah, so now we are scanning all of Reddit comments in real time. This is not indexed, this is raw data. And we're processing, BigQuery is looking at all the results. It went over 350 gigabytes of raw data in 10 seconds, 60 million rows. And the answer is... Oh, these are the top directors.
That's nice.
Oh, which one did you guess? Sorry.
I guess J.J. Abrams.
Lucas.
So.
Yes, George Lucas. Yes, you were right.
Yes, I just couldn't come the name. So
Yes.
should we walk over and talk about this some?
Yeah, come on over here. Let's step away. Let some other people play.
So Felipe, tell us a little bit about how this was built. Like what's going on behind the covers here?
Yes, so the product, Google Cloud product that we want to feature here is Google BigQuery.
Okay.
That lets you analyze terabytes of data in seconds.
Yeah.
And that's what we were just saying here.
Cool. And so tell us, so BigQuery is our data storage technology, query technology?
It's an analytical database.
Okay.
If you want to analyze data in things that used to take you hours or days,
Yes.
now take you seconds.
Yes.
And you only need to know SQL.
Okay, great.
Yeah.
Yeah. So I know just enough SQL to be dangerous. I mean, do I have to be kind of a big data expert to?
I think it's super easy and fun to start with. If you want to get started, just get to the web UI and start writing queries.
Yeah.
There's a lot that you can learn from other people. People, especially with open data, people love sharing their queries.
I see.
I do that a lot on Reddit. There's a subreddit especially.
Oh, you have to tell us. Tell our viewers where the Reddit is.
So if you go to reddit.com/r/BigQuery, you will find a big community of people sharing data, sharing queries. It's really, really fun.
And it's a great way to experiment with big data and to learn BigQuery, learn the syntax and...
Exactly. So there's a lot of people using BigQuery for their own private data.
Right.
And that's super private.
Right.
But at the same time, we're able to share open data with everyone. Here we have Reddit, Wikipedia, page views, that's 50 billion page views a month.
I was going to ask, so can people at home, can they actually use the data that you used here?
Yes, all of these data sets that we are playing with today are shared publicly. And people just need to go to cloud.google.com/BigQuery. And the best news is everyone gets a 3 terabyte each month to write queries. So,
Great. So you can use
no
that
excuses,
to query over your own data or free data on the thing.
Exactly.
Yeah.
Can you tell us about some customers that you know of that are using this? Is anybody we might have heard of that's using BigQuery?
Yeah, there's a lot of people using BigQuery. The hard part is discovering it, but once you know that this exists, people really love it. Today we have 3 big customers talking about BigQuery today. We have Spotify.
Oh, Spotify,
yes, they recently went all out and started telling everyone how much they love BigQuery. So they will be presenting their use case here. We also have today Kabam. Kabam is a
that's a big game, right?
Exactly. Gaming company. Online gaming generates so much data these days. For them to be
and really, you have for games, you have to get insight in that data and really know what.
Exactly. Having data available makes Spotify a better music provider. They can give you better recommendations. For a game designer, knowing how your players use your game, where they are stuck, where they are spending more money.
Right.
You have a pay-to-play game. Being able to analyze and understand all that is happening in real time.
The real time, I guess that's a big difference because people could do these queries that might take hours or days, but with BigQuery, it's faster.
Exactly. If I'm a game designer, I want to know how people are playing now.
Right.
And I want to be able to have a dialogue. I want to be able to start questioning my data, discovering patterns, and not waiting hours or for someone to code it.
Right. That's how insights are built, when you can experiment with the data and go.
Exactly, Just the ability to play with this. I recently loaded, I hope this will get a lot of people excited.
Oh, yeah?
Do you know Dota 2?
Say it again?
Dota? Dota is, there are a lot of people in Dota, yes.
You know it? Our kids with it, okay.
Yeah, so I loaded 3 million games of Dota into BigQuery, and now people are able, I set that up as open data, so people are able to query that and start looking for patterns, looking into how they can play Dota better.
Oh, that's cool.
I used to think of the data scientists, data analysts using spreadsheets and kind of looking at the data. It's not just about making them more efficient at doing spreadsheets. It's about putting those insights into the application itself, right? Is that really where it makes a big difference? It's not just for some guy to look at the data, but actually to drive the application behavior, right?
Exactly. So there are so many stages of data. The first one is how are we able to gather all of our data and able to ask questions over it? And that's the first level. But then we can go to how do we use data to improve our products? How do we use this data with machine learning? How do we start making the computer smarter just by being able to access all of our raw feeds?
So if people are getting excited about BigQuery and what's the easiest way for them to pull their data into the cloud, or how do they get started?
Yeah, so to get started with BigQuery, the easiest way, and you can be doing this in the next 5 minutes, is just open it up, create a Google Cloud account, and you will be able to, for example, query all of Wikipedia page views. That's 50 billion page views a month, and you will just be able to start with that. Now, if you have your own data, if you have it in CSV format or JSON format or Avro, you can load it in BigQuery. Doesn't matter how huge your data is.
There's some kind of streaming input too, so you can...
Yes, even you can input streaming data to BigQuery. Up to 100,000 rows per second per table.
100,000 rows per second. That's a lot.
And there is nothing to set up. The service is just running. There are no servers. There's no RAM. There's just ready for you to analyze data.
Awesome.
Well, thank you so much for showing us around here.
Thank you.
All right, thanks a lot.
Have a great day.
All right.
So
thanks.
we've got one more stop on our tour of the GCP Next Playground, and that is to check out the Tetris booth here with our friend Brian Dorsey, and we're going to talk a little Kubernetes, I think.
I can't imagine how Tetris is going to relate to this, but we're about to find out.
Brian will fill in the details for us.
So are you winning, Brian?
Oh, I'm amazing at Tetris. No, awesome. I'm not. So, hi, everybody.
Yeah, so say hello to the live stream. That's good. So tell us, what is Tetris got to do with Google Cloud Platform?
Oh, so actually we're here as a metaphor for scheduling containers on Kubernetes. So if you've got a cluster and you want to use it really efficiently, you've got kind of a bin packing problem. So you've got these different shaped objects, and you want to put them all together and use them efficiently.
Okay, so I think so take a step back here. So containers, tell the audience here what containers are about, why they're interesting.
Right, so Docker has really popularized containers, and a short way to think about it is it's everything your process needs to run. So all the files and the actual binaries and everything it needs to run. So you've got this nice little container, and you can run that anywhere. So that's awesome. And then we have Kubernetes, which is an open source project to run containers across an entire cluster of machines. That's the really short version.
Well,
That's awesome.
Okay, for those who don't know, I'm going to play dumb here. I've got my Kubernetes bracelet on, and some of you at home might know my relation to the project. But Brian, where did the word Kubernetes come from? Can you tell us about that?
Oh,
Trivia
right.
question.
Okay, so I'm gonna mess up this pronunciation, but I was told it's pronounced something like Kuvernetes in Greek, which stands for helmsman. But it originated on the west coast of the US, so we say Kubernetes.
Kubernetes, bro.
And a helmsman, help me with that, helmsman.
Okay, so you've got container ships, you need to steer the ship.
Okay.
Yeah, we're kind of like orchestrating.
I see.
We're making sure they end up in the right place.
So tell us a little bit about maybe the history of the project, what's going on with it,
Yep.
why people should care, why do people probably hear about the hype of containers, right?
Right.
Break it down for us.
I mean, the why you should care, like fundamentally, is so you can focus on building your applications and take a lot of the things that are normal operations and automate them. So Kubernetes is one way to think about it is it's a toolkit to handle all the stuff you run into in distributed systems regularly. So when you start trying to run a bunch of processes on a bunch of computers, they're going to have to figure out how to find each other, how to get load balancing going, how to keep them up, that sort of thing. So Kubernetes handles all those. But where did it come from? So it started from several folks at Google internally, and they're like, the time is right to kind of spread the word about we've got some patterns we know work. And so they made an initial version and immediately made it open source. And so from there, we've now
Wait, Brian. So an initial version, they invented it from scratch? I mean, where did this come from? Come on.
Okay, so this comes from many, many years of experience inside of Google running large distributed systems, right? So these patterns, these particular engineers didn't just invent them, right? They were happy using them and wanted to use them in other places. Want everybody to be able to use them, right? And so not everybody's going to run on Google Cloud necessarily. I know that's I said it online. But so Kubernetes actually runs on AWS, on Azure, on your own machines, and of course really well on Google Cloud. And so it's an open source project, and once it became open source, we very quickly had lots of really great ideas and implementations coming from the community very quickly, and taking things in directions that Googlers probably wouldn't have thought of, but that make the whole thing much stronger and easier to use.
So Kubernetes, again, dumb question. Kubernetes, nobody's running containers in production, right? So, I mean, who could possibly be doing that, Brian?
They totally are. There's tons of folks. We got a bunch of Red Hat folks doing stuff. CoreOS is all in. Actually, there's probably some other
we got Zulily.
You tell us.
We got Zulily up in Seattle, for example, and there are many other companies running Kubernetes production. And didn't we just have a release recently?
Yes, 1.2 is out, and it helps with a lot of things like deployment. So Kubernetes is very declarative. You say, I've got a web server and I've got a cache. I want to have 5 copies of my web server running and 2 copies of the cache. You send that to Kubernetes, it finds out where to run them in the cluster, and then it keeps it that way. So if one of those crashes at 2 in the morning, it's not your problem. Kubernetes will find a new place for that, start a new one up, get it into the cluster, and keep it working. What's new in 1.2, one of the new things, is actually deployments. So you can do a rolling upgrade managed by the cluster. So when you have a new version of your software, you can say, Kubernetes, push this out, but only if it works. And if it doesn't, roll it back.
So if I'm running containers, let's say I bought into the hype for a second. Okay, let's just say that. And I want to run containers on Google Cloud. What are the tools in my toolbox? What are the options I have?
Yeah, you have multiple options. And the easiest way to get started with Kubernetes, to just see if the patterns fit with the way you work, actually wherever you plan on running it long-term, is to give Google Cloud, to give Container Engine a try. So Google Container Engine, which it's a C, but we abbreviate it GKE because Kubernetes.
And the K is silent, as we like to say.
The K is silent. So, and that's a one-button setup of a cluster. So when you've got a new cluster and you want to get it up and going, just give it a try. So you go there, click one button, and you're good to go. So GKE, App Engine is an option, and Google Container Registry, of course, right, are all tools you want to use. Well, we're getting to the final wrap. The keynote is about to start.
Thanks, Brian.
Absolutely.
We have to go. Thank you, Brian. You've been joining us on the live stream, and we've had a chance to tour the playground.
So coming right up, we've got the keynote. We'll be joined by surprise guests.
Yes.
Eric Schmidt, our chairman, and Sundar Pichai, our CEO, will be there. So during the keynote, you can scroll down to the bottom and enter answers or questions for Q&A for live responses. You'll get an answer, and I think we're going to send you there now. You can get ready. Thank you so much for joining the tour this morning. Enjoy the keynote.
All right.